In this video, I'm going to talk you through how to analyze the graph of a polynomial function given an equation, and we're going to talk through how to find the degree, end behavior, the roots of that function, the y-intercept, and then how to graph it and find the increasing and decreasing intervals as well as domain and range. So lots of stuff going on in this video. Alright, this problem I took from the homework for analyzing polynomial functions. So you're starting off with this equation, f of x is equal to 1 over 7 times the quantity x plus 1 squared times 2x minus 7. Alright, we can pick out a couple of pieces of information to begin with on this. For the degree, you want to look at each x and look at the power it's associated with it. So for this first one, we have x plus 1, the quantity squared, that counts as 2 x's. And then for the second one, we just have 2x minus 7. There's no power on the outside, so that counts as an additional x. So 2x's from the first and 1x from the second makes this a degree of 3. Degree says a lot about the function. Degree tells us, in this case, there's going to be 3 solutions. So whatever the degree is, it's equal to the number of solutions. And it also tells us roughly how many times the graph is going to turn. So at most, and it doesn't have to turn this many times, but at most, the graph could change directions 2 times. So we call those turning points. So at most, that graph's going to change direction 2 times. So you can already kind of picture a graph that turns twice. End behavior is going to give us a little bit more information. End behavior, you look at the coefficient out front, whether it's positive or negative. In this case, it's positive. So for end behavior that has a positive leading coefficient, it's going to end, the graph's going to end on the right going up. And then we look at the degree. In this case, the degree is odd. So that means that that graph's going to alternate end behaviors. So the degree, along with the end behavior, if we put those two things together, we might have a graph that looks like this. So notice on the left it's going down, on the right it's going up. It's turning at most 2 times. We could also have a graph that doesn't turn twice, but still has a slight curve to it. That could also be our graph. We'll know more about it when we use our calculator and when we figure out what the roots are. So for the roots, we're going to look at the x plus, the sets of our factors, the x plus 1, and set that equal to 0, as well as the 2x minus 7 and set that equal to 0. So solve for x in both of them. So we get x equals negative 1. Now, before we move on to solving the other one, notice the power that was on the x plus 1. That one has a power of 2, which has what we call multiplicity of 2. Instead of writing out multiplicity, I'm just going to write multiplicity of 2. That tells us a lot about the graph. If it has a multiplicity of 2, it means it's just going to touch the x-axis at negative 1, or it's going to kind of, in a sense, bounce off negative 1 on the x-axis. So that gives us more of an idea, kind of leaning towards our graph looking more like this when we go to graph it, because it has to have that bounce. So imagine maybe the x-axis like that, and it's bouncing off of negative 1 here. We'll see. To solve the second one, so add 7 to both sides, and divide by 2. So x is 7 halves, or you could say 3.5, whichever you prefer. And since this one doesn't have any power on the outside, its multiplicity is 1. That also gives us information. That tells us that at that point on the x-axis, the graph's going to have to go straight through, or it's going to have to cross the x-axis at that point. So again, it really is looking like our graph's going to look quite like this. So we're going to go ahead and graph it. Now, if you're having problems graphing it in your calculator, I have posted 2 other videos. Look at the top of the Unit 1 videos to kind of see the links to those videos. They are done by a different teacher, but that teacher has the capability of showing you the graphing calculator on the screen, which at this time I do not. So if you need help on how to graph it in your calculator, please watch either one of those 2 videos and then come back to this one. So this is the graph that goes with the f of x is equal to 1/7 times the quantity x plus 1 squared times 2x minus 7. And then the negative 1, 0, and then the 2, negative 3.86 are both turning points on that graph, which you would have to use your graphing calculator and use the tool to find the local maximum and the local minimum. So now we want to look at increasing and decreasing. So as you look from left to right, kind of imagine if you were, let's say, walking on this graph, kind of how it would be. So from the left, you think of it, you'd kind of be walking uphill. This would be a section where the graph would be increasing. And then you're going to, at that turning point, you're going to change directions and turn, and you're going to be going down. So this would be decreasing. Then again, at that turning point, you're going to change direction, and then you're going to go back up. And this would be another section where you start increasing. So we just need to translate those intervals down into interval notation. Now remember, what's technically increasing and decreasing on the graph are the y values. So y is going up, and then y is going down, and then your y values are going back up again. And how we write increasing and decreasing, it's over what x intervals that happens over. So before you do that, it might be helpful to kind of fill in the starting and ending points. So in the first quadrant, all coordinates up there are positive and positive, which means that this graph goes to positive infinity and positive infinity. So as x goes to positive infinity, y also goes to positive infinity. If we fill in the second quadrant, even though we don't need it for this graph since it doesn't end up in this quadrant, it would be this. Third quadrant, all the coordinates are negative. So negative infinity. And then lastly, fourth quadrant, again, even though we're not going to use it, positive infinity and negative infinity. So when we go back and fill in the increasing and decreasing intervals, we're going to be looking at specifically just the x terms. So this starting point of this graph that goes down to the far left, it's starting when x is negative infinity, and it's going to go up to -1, and then we have another interval from -1 to 2, and then again from 2 to infinity. Okay, so just looking at those four highlighted terms, how we're going to fill this in is going to start increasing down when x is negative infinity, and your y value is going to increase all the way up until x becomes -1. And put round parentheses on both of those. And it's going to change the direction, start decreasing. So starting decreasing from when x is -1, and y is going to go down all the way until x is a +2. And then last but not least, it's going to change and it's going to start increasing again from when x is 2 to positive infinity. So in between those two intervals, we're going to put a u for the union of those two sets. So that's how we do increasing and decreasing. Domain and range for this one. The domain refers to all of your x coordinates. So as you move from left to right on this graph, if you stop at any point along the x-axis, so say I stop here, if I can move up or down and hit a point on that graph, that means that x coordinate is included in the domain. So imagine this graph's going to keep getting wider and wider. So it's going to go to negative infinity and to positive infinity, and any point along the x-axis that you stop at, you could move up or down and hit your graph. So that's what makes the domain all real numbers, or in other words, negative infinity to positive infinity. We can do the same thing with the range, but for range, we're looking at the y-axis. So again, pick any point along the y-axis. In this case, if you can move left or right and hit your graph, that represents a number that's included in the range. Now, since this graph goes all the way up and all the way down, and there's no stopping points in between, that would make this range as well all real numbers, which means anything from negative infinity to positive infinity is included in the range. I'm going to show you one more. It'll be number 2 from the analyzing the graphs, and I'm specifically just going to show you increasing and decreasing, and then the domain and range. Alright, so I've used my graphing calculator to graph this polynomial, and I labeled the turning points. So that's the -2.85 and 5.65, the 0.00, and then the 0.21. Alright, or 2.1 and 2.5. Alright, so to do increasing and decreasing, again, we gotta pick out where it's increasing and where it's decreasing. So from left to right, if you like, I'm going to highlight. So we're going to increase. We're going to start increasing because it's going up in an upward motion. Hit that turning point and we're going to decrease. It's going to go down. We're hit another turning point, so we change direction yet again. And then another turning point, and then the last section, it's on a downward trend. So we have, notice we have two sections where it's increasing and two sections where it is decreasing. Just like on the last one, we're going to go ahead and fill in the negative infinity and positive infinity symbols. Now on this one, I'm just going to use the two quadrants that have the end behaviors of the graph, so the third quadrant and the fourth quadrant. In the third quadrant, every term or every point is negative, so that means this graph's going to be negative infinity down here. And in the fourth quadrant, all the x terms are positive, and then all the y terms are negative. Okay, so now we just want to take a look at the first terms for these. So remember, when we write increasing and decreasing, we're writing it in terms of the x values. So I'm just going to go through and highlight those so we can focus on the x terms. So every turning point, highlight its x values, and then the end behavior, we're going to highlight the x values there. Alright, so it's going to start increasing back when x is negative infinity. It's going to increase up until x turns into negative 2.85. That's one interval. Then we're going to decrease from that same turning point up top all the way down to when x is 0. At this point, we're going to change direction again and go up. So it's going to start increasing. We're going to use that u in between for the union. From when x is 0 to 2.1. And then finally, we're going to start decreasing again from when the x coordinate is 2.1 until x goes to positive infinity. Alright, so for domain and range for this, domain we're going to check the same way. Again, domain goes with your x. As you move from left to right, think about if you were to stop at any point and move up or down, would you hit that graph? And again, this graph's going to continue to get wider and wider, both in the negative infinity direction and the positive infinity direction. So domain for this polynomial, and all polynomials really, is all reals. That means from negative infinity to positive infinity, you could stop at any one of those points, move up or down, and hit a point on your graph. And then range, we're going to look at just the y-axis. Alright, so range are your y values. So if you look here, imagine if you were to, I know my note goes off the graph, but imagine if you were to go up to positive 10. We know that this graph stops here at the point negative 2.85 and 5.65. It does not get any higher than that. So the range for this is not going to be all real numbers. In this case, you need to figure out the lowest point that the graph reaches and then the highest point that the graph reaches. So if you look at this graph in relation to the y-axis, the lowest point that this graph's going to hit, well, there is really no lowest point because it goes down all the way down to negative infinity. So we always put the lowest point first. And then as you move up, you're going to keep moving up, and then until you find the highest point that that graph reaches. In this case, it's right here. Now, since we're talking about range and range are your y values, the highest value that your y coordinate could possibly reach is 5.65. Now, the graph does actually hit 5.65. It does equal that for your y coordinate, so we put a square bracket on that. That's different from the negative infinity. Infinity, when you're dealing with domain and range and interval notation, always has a round parenthesis around it because it's not a tangible number. Whereas 5.65, the graph does actually, you can see that point, that does count as a tangible number. So hopefully that helps with domain and range and increasing and decreasing, and I will see you later.
Made with Doodlecast Pro.